Hopefully you guys have had a good day so far. Good afternoon to everyone, and welcome all the virtual attendees to this event. We have a really great session here with PeopleFlo. I guess we'll start out with some introductions and then get right into it. My name is Leonard Snyder. I'm the sales director at ZEDEDA. PeopleFlo is one of my customers. I have been in the IoT space for about 15 years, believe it or not. IoT or remote service, and work for companies such as ZEDEDA, PTC, Cisco, and very excited to be with ZEDEDA now as we're doing some very unique things in edge compute and edge virtualization, of which IoT is a subset. So today what we're going to talk about is PeopleFlo, kind of as a company, where they come from, how they get their expertise. We're going to talk about their product that they're running with ZEDEDA, which is called Machine Edge. And then we're going to talk about their journey and exploring edge architectures and their journey with ZEDEDA. So PeopleFlo is very exciting as far as their use case. One of the best I've seen for IoT because they deploy artificial intelligence at the edge, and not just the architecture is super great, but the results. They get great results in power savings, in equipment health and equipment longevity, and CO2 emissions reductions. So anyway, I'd like to introduce Mike Thompson. He's the VP and CTO. And Mike, why don't you introduce yourself real quick?
Yeah, thanks, Leonard. So as Leonard mentioned, I'm the Vice President and CTO here at PeopleFlo. I call PeopleFlo sort of an established company turned startup, and we're based here out of Chicago. Personally, I'm a mechanical engineer by degree. I've spent a lot of time in software development and electronics design throughout my career as well. So I have some experience there that pertains to where we're headed with this Machine Edge product. I started at PeopleFlo about 5 or 6 years ago as a product design lead. Mostly designing pumps. Eventually we ended up turning our full attention to Machine Edge, which is the product we'll talk about today. But before that, it was mostly pump design for me. And then before that, worked for a company called Elliott Group out of Pennsylvania, designing lube oil systems, gas seal systems for compressors and turbines. It's the same type of markets that we served there that we're hoping to serve here with Machine Edge as well, like refining, petrochemical, chemical, those types of markets.
Okay, great. Thank you. Can you tell us a little bit about PeopleFlo and kind of the background of the company and how you got into, the current business?
Yeah, sure. It's a pretty interesting story. So we started about 17 years ago, I believe, as really a pump company. So we started with sort of an innovative sealless gear pump design that we manufactured and sold out of this same facility that we're in today. But along the way, we had these ideas, new ideas for innovation, saw some new opportunities, and all of that sort of got sidelined by the day-to-day operations of running a pump company. So I think it was in about 2012 that we sold that product line and transitioned to become more of a product design and innovation firm. So we had a few types of projects there where it'd be, an OEM might approach us and say, we're interested in this type of product, and we would design it out for them. And there were some opportunities that we saw in the market, some gaps in the market. And in some cases, we would, take our own initiative to design products to fit those gaps, and then, try and find homes at OEMs for those products. I think, it's probably shortly after I started here, mid 2000s, mid 2010s, or maybe a little bit later, but we started to get a lot of inquiries about IoT product lines, condition monitoring products, things along those lines. And we had a sort of revelation there, which was, really the best opportunity to create value for pump system end users isn't really to deploy some condition monitoring system, in isolation, but rather to tackle the main reason that these pump systems are failing, which is that the equipment is often operated in an inefficient and low reliability state. So that led us to work on the solution, which is this product that we call Machine Edge. And eventually, I think around 2018, we realized that it had such big potential that it deserved our full attention. So we pivoted once again, sort of back to startup mode, to focus, exclusively on the development and commercialization of Machine Edge.
Okay, so before we get into the Machine Edge, tell us a little bit about the use case, the problem statement for your customer, and why you developed Machine Edge in the first place, I guess.
Sure, and it gets a little complicated, so if I don't explain something clearly, just feel free to stop me, Leonard, and I'll take another shot at it.
Yep.
But we really need to think about this in the context of a typical control loop that you might see in an industrial process. So typically you'll have a centrifugal pump, which is driven by a fixed speed motor. So just driven at the line frequency at whatever nominal speed the motor is. And you have a control valve downstream that maintains a process variable at some set point. And in most of my examples, I talk about flow control loops just because they're so easy to understand. So, if I give an example from here on out, it's probably relating to a flow control loop. But centrifugal pumps can operate anywhere along their head flow curve. And for those of you guys that aren't that familiar with pump curves, we can think of head as pressure in this scenario. So essentially a pressure flow curve, and it can only operate along that curve. But it's specifically designed to work at what we call a best efficiency point, BEP. That's where it works best. There's sort of a preferred operating range around there, which is typically 70% to 120% of BEP flow. So if BEP was at 100 GPM, your POR would be, your preferred operating range would be between 70 GPM and 120 GPM. So that's really the sweet spot. When you start to move away from that, when you start to move away from BEP, your MTBF really goes downhill quickly. There's a pretty slim window there where you can get relatively high MTBFs, and then it drops off pretty drastically.
Mean time between failure, correct?
Yes, I'm sorry. I use
a
lot of abbreviations.
I'm sure our audience knows these things, but
yeah. So there's one potential issue, for a process which might be that it just can't operate near BEP just due to process variability. So sort of as an example, consider a pump that has a BEP of 200 GPM, but the process requires it to operate at 100 GPM or 300 GPM. So you're spending a lot of time at 50% BEP, 150% BEP in those low reliability areas. And there's serious reliability implications of that, and that's where we see a lot of pump failures resulting from that type of thing. Sort of a bigger problem is that the equipment is in a way it's systematically oversized. So an end user might intentionally specify a pump for 125% or 150% of the actual required capacity, just so there's some deviation between how they design the system theoretically, how it performs in real life, that they want to be able to accommodate. They want to be able to accommodate future demand changes, that sort of thing. So systematically oversized, but what that does is it pushes sort of the normal operating point of this pump further from BEP. So that's also a critical issue. And the oversizing of pumps leads to the oversizing of control valves. So then we see these control valves that are operating, pretty far closed, which is in a less reliable state, and is an indicator of wasting energy, which I'll get to in a second here.
Okay.
And wasting energy, you're also putting more wear and tear on the motor. So those are sort of the reliability factors. In terms of the energy, we estimate that maybe 50% of energy consumption is wasted just because of how these systems operate. And if you think about it sort of from the control loop perspective again, we have this motor running at fixed speed coupled to this pump, adding all this energy to the fluid. Then we have a control valve that's throttling that flow, pulling that energy back out of the fluid. So one analogy that we use very often is that it's like driving a car where you have one foot on the gas pedal, pushing it to the floor, and you use your brake to modulate your speed to get around town. It's not a very efficient way of doing things. And think about that again in the context of a control loop. If we had a control loop, and again, let's say maybe a 200 GPM set point, the pump curve might say that your discharge pressure is going to be 100 psi at that flow rate. But the process doesn't really care about the pressure. The process is only care about maintaining that 200 GPM flow. Mm-hmm. So if we were to reduce that pressure somehow to 50 psi instead of 100 psi, that's fine with the process control system, but it's just not an operating point along the current pump curve. So we can't get there. It's not a possibility. So essentially, it's a long way of saying that there's an opportunity to reduce speed. Reducing speed of the pump shifts that pump curve down. And there's going to be some point where we can intersect that line where we can get 200 GPM and 50 PSI, still providing the flow we need, but saving a lot on energy. And, as a result, the CO2 emissions as well.
Yeah, I think you have a graphic on that, correct? So I guess how does Machine Edge help solve the problem? I guess, I've heard from other, people that pumps in industrial applications, what's like something like 25% of total energy used is just for pumping fluids.
Yeah, it's definitely a big cost for these types of facilities. And if you're looking at pump life cycle costs as well, I think don't quote me on this, but I'm going to be in the ballpark. I think something like 80% of the total pump life cycle costs relate to reliability and energy. Yeah. So those are the two areas we're attacking. So we expect we can drive that cost down.
Yeah. I heard in some of the other sessions, people believe that the analytics at the edge is still not there yet, but I believe you actually have a use case where it is there and you're getting real world results. So.
Right. Yeah. So what Machine Edge is sort of like it's an intelligent edge for pump systems is one way to categorize it. And there's lots of ways here that we can add value, either now or in the future, but mostly what we're talking about today is the sort of optimization system. And what that tries to do, which I think I've already alluded to here, is maximize the reliability of the pump, the motor, and the control valve in a given control loop, while also minimizing power consumption, sort of simultaneously.
Okay.
And we do this by resetting what we call the baseline speed. And we call it the baseline speed because we're trying to make an important clarification here, which is that Machine Edge doesn't control speed to control a process variable. What we're doing is more like changing just the fixed speed of a motor and leaving it there. And then we work with the existing process control system, including the control valve, so that we don't need to make any changes. So when we first set out to tackle this problem, that was one of the biggest initiatives we had, was to keep it out of the customer's process control system, because that gets really expensive, really complicated, and people, frankly, they don't want to do it.
That means you don't have to run network cabling back to their control system. You're just completely contained in your own architecture near the pump that you're monitoring and controlling.
Yeah, exactly. We don't, it's one thing to sort of stay out of the process control system in the sense that we're not receiving commands from the process control system, but like you're alluding to here, we also don't even need any information from the process control system. Mm-hmm. So you might imagine that we would need the flow rate or we would need the set point in order to do this. But what we've come up with is sort of like a plug and play installation is how we describe it. And that we install it between the motor starter and the motor. And it gets all the information it needs from the power running between the motor starter and the motor. That's its only connection. Nothing to the control system at all.
Do you want to show your graphic there and explain more how you're solving the problem?
Yeah, I would love to attempt to do that.
Keep your fingers crossed.
Yeah, it does get a little bit complicated. So we wanted to show a video. Can you see my screen? Yeah, okay, that's good.
I can see it.
Okay. Yeah, so it gets a little bit complicated to describe this stuff, just verbally. It's better to use some visuals. So we have this quick demo video. It's only, a minute long or something like that, but just to illustrate the concept that we're talking about. On the top, we have a typical control loop, again, a flow control loop. We see our control valve, which is modulating flow to reach a set point of 125 GPM, which we see there on the top. We're also showing, discharge pressure, which is really just a consequence of everything else. It doesn't really play into the system, and power, as well as the speed. On the bottom, we're showing the same thing, but just with machine edge. So we have that, we're showing that style of plug and play installation again, where we're essentially just taking the leads that were going to the motor, run them into machine edge, and then running new leads from machine edge back out to the motor. And on the left here, before I click play, we have some indicators, pump reliability, control valve reliability, and motor reliability indicator, as well as energy consumption. But just to touch on those very quickly, the color scale is sort of arbitrary. We're just trying to convey a point here. But, you imagine that 100% of BEP, the most ideal operating point, is just dead center of that green section on the pump reliability bar. Control valve reliability, generally you don't want to operate below 20%. You don't want to operate above 80%. In between there, not a huge difference. Motor reliability, you slow it down, you get less wear and tear, less load as well, results in less wear and tear to a certain point. And energy consumption, obviously, the lower the better.
Yeah.
So I'll click play here. And what we can assume that machine edge is doing right now is sort of learning about the process conditions and picking a target speed. And when it establishes that target speed based on what it estimates, the position of the control valve is and the flow rate and all these other variables, it'll make a move to that target speed. And we should be able to see that here shortly. Okay, we are playing.
I think one thing that's obvious about this, though, is you definitely, in order to be doing edge intelligence, you have to be a subject matter expert. This is not for this is not for some IT company to come along and just deploy. You need to really be a subject matter expert in the technologies that you're monitoring and controlling.
Exactly, and that's I'm sure we'll talk about this a little bit later, but that's what brought us to you guys, right? Is that we have all this pump and pump system expertise. What we don't have, or at least we didn't have when we got started, was expertise in IoT and managing remote applications at scale and that sort of thing. So even ZEDEDA has really enabled us to take that on. But I did have some difficulty with the video there, but I was able to fast forward to the right spot. This must be a wrong edit of the video, but now we'll see it start to change speed. Yeah, there we go. Speed's dropping. We see pressure dropping. Now, what we also see here is flow dropping a little bit. But what the valve's doing is it's opening up to compensate for that. And further as speed's dropping, we see this power dropping. And a lot of this, in terms of pressure and power, is just due to the affinity laws of centrifugal pumps and other centrifugal machines. This is nothing novel that we've created. It's just based on physics here that we're seeing these benefits as we reduce speed. So again, you see the control valve opening was 43%. It's now at 50.
This is all without human intervention, correct?
What's that?
This is all without human intervention. There's not something there. Yeah. Okay.
Yep. It's totally autonomous. And it doesn't change speed very often. Like we said, it's just resetting a baseline speed. It's not continuously controlling. If there is a significant change to demand at some point, it'll react to that, change speed accordingly. But for the most part, it gets to a point and it just stays put. So just, comparing some reliability indicators here, I'll just hit pause. So during that transition, we had the flow drop quite a bit. Well, not quite a bit, but it dropped maybe 5 GPM. The valve opened up to compensate for it and now flows, back where it started essentially. In real life, if the control loop was tuned like this, we would have the machine edge make slower speed changes, but that's sort of besides the point. So we reduced speed from 3510 to 2,240. We got a huge pressure drop, and we got a huge power drop out of it. I think I checked this earlier, and it's about 65% reduction in power, which is pretty impressive. And with the new climate-oriented initiatives, you can equate that to a 65% reduction in equivalent CO2 emissions as well.
Okay, that's great.
And we pushed, in terms of pump reliability, we're in a much better situation. Control valve reliability is about the same. We were in a good place before and a good place after, and motor reliability is improved. So overall, a beneficial move for all equipment. And that's, really what we're setting out to do here is find the best balance between these things to, improve the longevity and energy consumption of the whole control loop.
So earlier you alluded to the fact, I mean, obviously you're the OT subject matter expert here on pumps. What were the actual issues that you were having with Machine Edge in relation to IoT or edge compute?
Yeah, so it's, I guess first, I'll explain a little bit more about what is inside Machine Edge, sort of fill out this question. It's essentially an industrial control panel. And inside of there, we have a VFD, which is really just our mechanism to control speed. We're not doing anything else fancy with the VFD. We have a PLC for local control. So it controls contactors, switches, indicators, stuff like that. And then we have an industrial PC. And that's really where our optimization application lives. It communicates with the PLC, which in turn communicates with the VFD. And we have a cellular gateway, for upstream communication. So, among the challenges we faced, one of them, for instance, was we wanted to locate this near the equipment, this industrial control panel. And there's a few benefits of doing that. We got short lengths of shielded cable rather than the alternative of if you put a VFD in a control room and you have to run, 300 feet of shielded cable and touch the process control system and all that stuff. It's pretty much cost prohibitive. You can't do it. We also wanted the ability to easily connect external sensors. We don't want to overcrowd motor control rooms. So there are a bunch of reasons that led us to want to put this out near the motor, near the pump. So we had to design it, to be Type 4X, Class 1 Div 2 rated, give it a high ambient temperature rating, minimize the footprint. A lot of heat management concerns, right? The power electronics we have in this industrial control panel are kicking off quite a bit of heat. So we had to design a sort of a novel cooling path to work with our air-to-air heat exchanger. But those types of challenges are what sort of we're prepared to deal with as a company. If I were to generalize our experience at that point in time, it would be a lot more mechanical engineering experience than software development experience, stuff along those lines. Mm-hmm. So when it came down to, actually figuring out how we were going to deploy this application at scale, there were a lot of questions that we couldn't initially answer. So in terms of challenges, the most important one for us was security. So while we're not directly involved in process control, there is an impact. We're adjusting speed. Again, we let the control system do its thing, but we have that lever on speed. So things that, we're looking into are, encryption, both at rest and in transit, TPM integration, physical security, locking down these devices, network segregation and routing, firewalls, allowing communications to certain endpoints, and everything's outbound request only. These are things we're trying to figure out how to pull off initially. Updates was another big one for us. And not necessarily just our application, but we need to update our application and all the rest of its dependencies and the other software on the system, right? So how do we go about doing that? And how do we avoid the risk of bricking the device in the process? So essentially, we'd like sort of an A/B type update system. Monitoring and logging concerns. Again, it's not just the application, but monitoring the physical device itself. What's its memory usage? When's the last time it's restarted? What's the status of the application? Is it running? Is it healthy? And keeping the application running if it's not started or or if it's shut down for some reason, what's watching over our core optimization application to keep things moving.
So is that when you learned kind of what we call the edge, or the industry calls the edge? Is that the type of stuff you were then decided to look for?
Yeah, at this point we're deep in sort of edge technologies, trying to figure out what sort of software we can deploy at the edge to help us. And again, it's because we have a certain expertise in pumps and pump systems, and in areas that we aren't, that's a little bit out of our wheelhouse. We've always had the philosophy that we want to collaborate with some expert partners, sort of like yourselves in that industry. So we don't want to reinvent the wheel. We don't want to take on all these, all the things I just listed. We don't want to be responsible for developing solutions to those. So we're looking for various edge technologies that we can deploy that will fill some of these gaps and sort of take it out of our hands.
Okay. How did you learn about ZEDEDA and the other partners that you're working with?
Yeah. So, I don't remember exactly how we had learned about ZEDEDA, but it was after we had spent quite a bit of time, considering various options. And, I can sort of fill you in a little bit on, that process.
I think you guys learned about us through Microsoft and Azure, I believe.
Yeah, we may have. So one of the first decisions we made was to use Azure, mostly as our, the initial decision was sort of as our cloud service provider, our cloud platform. But they're a leader in the IoT space. We like their IoT initiatives. We got into the Microsoft for Startups program, so that all became a pretty easy decision on our part. And then we sort of set out testing their IoT Edge platform. It works in conjunction with IoT Hub, and there was a lot that we liked about that. It sort of had the modular containerized architecture to keep certain portions of the logic isolated, certain functions isolated. We like the structure of Edge Agent, Edge Hub, the Edge Agent doing fetching the images to manage deployments, Edge Hub handling the routing between different containers, maintaining the attestation, and establishing connections to the cloud endpoints. It's all stuff that we don't have to build out ourselves. Also, like the synchronization of device and module twins is something that we used pretty heavily. And what maybe most importantly, it's just easy for us to get started. To just write a module to do our core optimization wasn't a huge challenge. It was pretty simple to do. But there were a lot of other things that we considered, and a number of them were more like a SaaS type solution where you're running their application at the edge, and it communicates with their cloud, sort of their managed cloud platform. And you can configure, some sensors at the edge using some, standard plugins, that type of thing. Mm-hmm. But there's just a lack of flexibility all around there, and it was difficult to take our optimization system as we envisioned it and tested it, and designed it, and fit it into those sort of architectures. And there were some other ones that were similar on the cloud side, but they had less features at the edge. Essentially, they give you an SDK and you build your own application, which gives us the flexibility, but also leaves a lot of responsibility on our plate for development. And just in general, sort of browsing around the various products, to provide a solution for us, there was a lot of things that would trap you in with a certain vendor. There was a lot of convoluted pricing structures. I think in one extreme case, we saw that we'd be paying by data point that we send into their cloud platform. And it's just not particularly straightforward. So what we were mostly looking for was a solution that sort of fit our vision for the product, for the optimization, without jumping through a lot of loopholes, or a lot of hoops is what I meant to say. One example, I guess, is we've been approached several times by guys that work on PLCs or similar PLC-like products, and they say, "Well, can you do it in ladder logic or structured text?" And the answer is maybe theoretically, but it's not worth it. It's not practical. So we needed something that fit. We needed something with a lot of flexibility, but also is taking some of those challenges I mentioned off the table, and is low cost and has a clear pricing structure. So we ended up going with IoT Edge. But that being said, there were a bunch of challenges that it still left on the table, which was we can update our application easily with IoT Edge. But what about the remaining software, like I talked about before? What about the IoT, daemon itself? How do we handle that? Doesn't do much in the way of monitoring devices, that sort of thing. It can monitor its own applications, or its own modules, but that's about it. And we're trying to figure out who is sort of responsible for managing our base images. Like at this time, we're picturing, we'll have some OS image and we'll push it to a device, run a config script, and it's ready to go. But who's setting that up? That's something that we want to be involved in, but it's also, more work on our plate, and a few of the things that I, had talked about before, which eventually, pushed us to ZEDEDA. So I think really you guys came around at just the right time for us when we were thinking about taking on a lot more work than we really wanted to take on, given, the point I've stressed here multiple times, which is we're not adding a lot of value if we're recreating the infrastructure sort of just to enable this application. We want to focus on our own applications that are adding a lot of value. Mm-hmm. So, with ZEDEDA and with Eve, now we get full control of all the software. We can push updates to Eve. We can push updates to the VM that has IoT Edge. We can deploy new VMs, new containers to support, future applications. Like, we're considering doing that now already, and it's easy to do, which is a great thing. And we don't need to be worried about bricking the device, which is an important thing for us too. It can always be recovered. And like I was mentioning before, with the base images, now we're able to get started using ZEDEDA's managed Eve image, which takes that off our plate. And ZEDEDA also has published a VM for IoT Edge, so able to get started with both of those just as a default, get us up and running quickly. And a few other things is, easy control of the network configuration, just quick simple stuff with the user interface, and you can apply it to all devices easily. That sort of stuff. Locking down ports, all the monitoring. Remote access is big. As much as I want to say that we shouldn't need remote access, it's just incredibly useful for troubleshooting. Yeah. And it's great that it can be turned on and off, right? That's important too, is we don't want to leave that open all the time. Mm-hmm. And it really just has provided what we think is a scalable platform for us. Now, I say that we haven't necessarily fully appreciated that, because we haven't scaled to hundreds and thousands of units, or hundreds or thousands of units at this point. But we can see that there's a good foundation there.
You do have a successful deployment at a large refinery, or a large refinery company. You want to talk a little bit about the deployment and results that you guys achieved?
Yeah, sure. So there's probably a lot that I can't share. But yes, we've demonstrated the machine edge optimization system, in a real world refinery, which is a great step for us to show that it doesn't just work in the lab here, but it works out in the field as well. And hopefully at some point we'll be able to put together some case study on this situation and get it released and share it publicly. But in terms of reliability indicators, we saw some significant improvements, like in terms of percent BEP. We were able to hit some energy reduction targets of 40 to 50%, which is very impressive. And again, same reduction in equivalent CO2 emissions. One of the biggest concerns we see from customers is, that are just learning about the product, is they want to be sure that it doesn't have to disrupt their process control system in any way. And that's an important thing that we had validated as well there. So it's just overall just an overall validation of the machine edge technology in general. And yeah, we're looking forward to growing it. I think I took up a lot of time. I just realized right now how much time I took up.
Well, that's okay. I mean, so we have about 10 minutes. We lost a lot of our audience. We've had people popping on and off, but if anyone has any questions for Mike about machine edge, PeopleFlo, their experiences with, IoT Hub or Eve or ZEDEDA, let us know. Not seeing any questions pop up yet, but okay. So what is I mean, go ahead and do it, and I'll cut in if need be. But what are some of the future? Where do you see machine edge going in the future?
Yeah, sure. So there's a lot on our plate right now. One thing is we want to sort of take our machine learning AI to the next level. One easy thing to tackle. Well, I want to say easy, but one good starting point there is to take some historical data that we have from these units, push it back through an ML system in order to update sort of the characteristic machine data that lives on the device. So we're thinking about things like that, how we can improve the core optimization, but we're sort of also looking forward to expand what we're offering here. So one thing that we're talking about now, and we're actually building some early prototypes to start testing, is electrical signature analysis. So looking at the electrical signatures, the motor, the voltage and the current from machine edge to the motor, and being able to understand some of the the potential reliability issues in the motor, like broken rotor bar, soft foot, misalignment, cavitation in the pump. Stuff like that we'll be able to detect just through the electrical signature analysis. And something like that, it can be deployed in applications where we, someone might not necessarily want the full optimization system, right? So we can package together what we call a machine edge light that can give insights into these types of issues. And really, I think what we want to do with the product is we want to take the machine edge data, the electrical signature analysis data that we're getting from other sources like the historian, and package these up to make some sort of holistic control loop insights, right? So we can detect some very specific things about the system that are really valuable to an end user that it's just not possible to get otherwise as it exists today.
Nice answer. So do you see other industries? I know we talked about the refinery. What other types of industries make use of these types of pumps and could benefit from this product?
Yeah, glad you brought that up. So what we're really looking at is it's not necessarily industry specific, but what we're looking for is continuous process industries, right? Things where pumps are running 24/7, 365 for the most part, because that's where we're going to be able to have the biggest impacts. So for the most part, it's oil and gas, petrochemical, chemical, pulp and paper, potentially some pharmaceutical. I think those are sort of the main industries that we're targeting.
Okay.
It looks like somebody has a question here, which is, were you able to get any form of delta updates instead of full image updates, OTA? The answer to that for me is no, but I haven't necessarily looked into that a ton. Everything we've been doing has been full image updates. In terms of updating Eve or updating the IoT Edge VM, it's always full image. Whenever we update a module that's within IoT Edge, I believe it only pulls layers that it doesn't have. So that's sort of a delta. But that's an IoT Edge thing, and not really an Eve or VM type of thing.
Yeah, that question comes from Nasser. We should take that question down. Maybe we can get back to you with the answer from our technical people. I believe that I do believe that it's a delta for upgrades, but I would like to confirm that.
Oh, you know what? Now that you mention it, I think that I've heard that before too.
Yeah.
I think that Raghu brought me up to speed on that at one point.
Yeah.
So yes.
Nasser, if you want to reach out to me, I can hook you up with our technical people to describe that. And then I guess, let's see, how much time do we have? We have 5 more minutes. How do you go about training your AI currently for deployment to the edge?
Sure. So, one place where we have AI is sort of in the calculation engine, if we want to call it that. That sort of adaptively makes decisions about how to calculate things based on what information is available and what the expected accuracy is of that information. But that's more of like a broader AI than an ML. Now, what we have to do, and where we see more applications of ML in the future, is sort of learning about the pump system to establish some of this machine data and characteristic data that's behind the scenes, mainly by studying historian data. And up until now, that process has essentially been manual, right? So we're given the data, we're performing the analysis ourselves. I think it's important that we learn about it through this manual process before we try and deploy something to do it automatically without fully understanding it. So at this point, I can't say that we use ML there, although I might have mentioned in this session already. I can't quite recall, but that we did do a study at some point about using machine learning algorithm along with historian data to sort of correct a pump curve in real time, and that proved to work pretty well. But in terms of putting that into production, we haven't done that yet.
Okay. Hey, you know what? I had one other question, but I think I misread our invite. We're supposed to be done at 2:05, so we're 2 minutes over.
Okay.
Should we continue for another question, or should we wrap it up?
I'm good with whatever you want to do. I'll do another one.
I just wanted if Sarah wanted to weigh in. Well, I mean, okay, just real quick. Hardware and security. Sorry, Sarah, you want to say something?
No, I was just going to answer your question. That's the only way I could. I have to pop into your session. The closing keynote is about to start in 2 minutes on the main stage.
Okay.
So we just want to make sure people have time to head over there as well to hear from Pierluca and Saeed.
Okay. We can wrap that up. I think you've done a great job of giving us a very in-depth and complete overview of what you're doing. I'm as I said in the very beginning, very impressed with your application and excited that you're my customer. And thanks a lot thank you for doing this with us. Thank everyone in the audience for participating or listening, and let us know if there are any additional questions.
Yeah, and we certainly appreciate you guys over there at ZEDEDA and sort of giving us this platform to share our vision for Machine Edge, and I look forward to continuing to work with you guys.